Hello, this is Tinaclon. In this video, we will take a look at the docking function of TRION. First, run Docker, and then run TRION. In the project window, if you click on New Project, you can check the functions provided by TRION as follows. Here, select Docking. The workflow proceeds as follows. And now the important steps are to upload the target protein, specify the binding site within the target protein, and upload the library compounds to be used for docking. In the prepared example, we will perform docking using the EGFR target protein and compounds known to have inhibitory activities. In the first step, upload the target protein structure. For the upload method, you can either upload a PDB structure you have downloaded directly, or, if you know the PDB ID, you can upload it directly from RCSB by entering the ID. Since the protein structure we are using now is a bit difficult to explain the following options accurately, so let's temporarily bring another target protein example. This protein is the KRAS protein structure. Inside the protein structure, you can see that it contains chain A and chain B, and also a coligand, GDP, and a magnesium metal ion. So you can confirm that it even includes cofactors. Among these, you must define the target protein structure that we will use for docking. We will use chain A, and we will also include the cofactors GDP and the magnesium ion. If you don't want to include them, you can uncheck them. After setting this, make sure to uncheck the coligand part. When specifying the binding site below, if you select the coligand, you can apply the autobox option, which means you will set the region where this ligand is bound as the binding site. We have made this process of preparing the target protein a bit easier to configure. So, going back to our example, the EGFR target structure currently consists only of chain A, and you can see that it does not contain any cofactors or other molecules. When specifying the binding site, if you know the coordinates of the binding site, you can enter them directly. But usually, since that's not the case, we use the coligand. That is, we set the area where this coligand is bound as the binding site by using the autobox option. After specifying the binding site, click Next, and the preparation for the target protein will be completed. Then, upload the compounds to be docked. If you check the input format, you will see that there is a part corresponding to the ID, or name, and you must include the smiles as well. Also, you can see that the values between these two must be in a text format separated by commas or tabs. Likewise, when uploading the prepared chemical input data, you can see that the part corresponding to the compound name is named Compound ID. The part corresponding to the smiles is Smiles, and there is one more additional column corresponding to name. After uploading like this, click Continue and enter the title of the project. You can also add some words to describe the project. After writing the description, continue with the default settings. And you can see in the summary what we have set earlier. You can check the input, the binding site information, and even the docking parameters. The docking method provided by TRION uses AutoDock Ganina. AutoDock Ganina is an open-source molecular docking tool that utilizes a PyTorch-based deep learning model to support more efficient docking and screening. If you would like to learn more about this method, there is a reference paper for AutoDock Ganina. Please refer to it. After that, click Create Project, and it will be completed. Soon, when you go to the project, you will be able to check that the docking is in progress.